Alright, so the last video was about the 4D part where we do the rational root theory, and for 4E, it basically talk about the cubic functions. Okay, I will do a quick summary up of the cubic functions, and there are some places that you might want to take notes on. So take a screenshot and or maybe pause the video and take some notes in your reference book, which will definitely help you with the secondary exam. Okay, so for a cubic function, firstly by definition, well, it's a cubic function is the highest, or say our leading term is something, or say a or x to the power 3. So you won't have a to the power of 4 in your function, or you won't have the variable to the power of 6 in your function. So the highest power would be 3 in your polynomial. And normally we could have 3 forms of our cubic function. Inflection form is when we write the function as y equal to a times x minus b to the power of 3 plus c. So this point b, c over there would be the point of inflection, or say the stationary point of inflection. So that is something like this. And this point over here, this point over here with the gradient equal to 0 is going to be your point or stationary point of inflection. Okay, so this is the inflection form. And second, we might have the factorized form, is when we try to factorize a polynomial into 2 brackets or 3 bracket time together. So this one, you might have a times x minus b times x minus c times x minus d, or you might have y equal to a times x minus b squared x minus c. All right, or you might have y equal to a times x minus b cubed. So that is, they are all factorized into only brackets now. We don't have any like dissociate. You don't have like any other random constant number following it. So that's our second form, the factorized form. And lastly, we have the expanded form, which is the case that you would see in our 4C and 4D, is y equal to a times x cubed plus b times x squared plus cx plus d. Okay, so these are the 3 forms of the function. And after we say about the forms of the function, we can consider when we try to draw our cubic functions, or when we try to find the root of cubic function, we also consider the x-intercepts, right? So for a cubic function, because it's to the odd power, if it's to the odd power, that means there's definitely more than one point that you're going to hit your x-axis, right? Because if it's the function is positive, you're definitely going like this way, or if it's negative, it's going like this way. So there's definitely one point that you're going to hit the x-intercept, or say the x-axis. So for our cubic function, there will be 1 or 2 or 3 x-intercepts, and we are just going to draw like the cases for them. So when they have 1 x-intercept, that is some example like x to the power of 3 plus x. Okay, this is 1 intercept. And if the function is negative, then with 1 intercept, it might looking like this: y equal to x negative x cubed minus x. Okay, and how do we know that there is 1 intercept? You try to factorize it. So x to the power of 3, you can factorize the x outside, that gives you x squared plus 1. So this is the point that where you can have 0 value to make the whole function equal to 0. But is there any possible value that you can make x squared plus 1 equal to 0? Not really, right? So therefore, this function only have the one point where you have the y value equal to 0, that is when x equal to 0. That's for this. Therefore, this function only have one x-intercept. Alright? So that's for one intercept. And how about for two intercept points? For two intercepts, they are different shape, but generally you would have one point that's like this, like just going across it, but there's another point that's a turning point there. So you are having like this kind of like quadratic shape over here. That's when a cubic function have two x-intercepts. And if you write this kind of function in the factorized form, that would normally give you y equal to x minus, probably minus 2 to the square times x plus 1, okay? Or say, if I write in a general form, that would be a x minus b square x minus c. So there is a repeated factor over here. There is a repeated factor for this b value over here. That's where you have this turning point like this. You're going to hit the x-axis at the point, but then you're going backwards. Continue the shape, continue the positive value for your y. So this is for the turning point where you have x minus b to the power of 2. That's you have this quadratic shape of hitting the x-axis. So similarly, if you turn the function into a negative 1, that might give you something like this. Okay, so now you have negative, for example, negative x negative 2 squared x plus 1. Alright, so this is when you have two x-intercepts. And lastly, when you have three x-intercepts, you would have function like this. But this is negative 1. So if it's a positive one, that will be looking like this. Okay, so you have 1, 2, 3 of the x-intercepts. Your function might looking like x minus b, x minus c, x minus d. Or you could have its negative function that is going this way, and you have 3 points that hit our x-axis. So y would equal to negative x minus b, x minus c, x minus d. Alright, so in the end, a general form, or say the positivity and the negative of the cubic function, if it's a positive one, okay, your graph will start from really negative values. No matter how many points of intersection you have, you're going to go from negative to positive. If it's a negative function, your graph would go in a negative way. So going from positively, no matter how many points of intersection you have, you're going to go into a negative direction. So you're going from positive into a negative one. Okay, so that's our cubic function, the x-intercepts and the general form or the general shape of our cubic function. Okay, and something I want to mention or say emphasize over here is for our turning point, as we just mentioned, if the function have something like this, as a turning point form with our x-axis, that means there is a repeated factor over these places. Okay, for example, x plus 1 squared times x minus 2. This x plus 1, because it's squared, so this over here, there is a turning point on the x-axis. And for our cubic function, the stationary point of inflection, like this one, where the gradient turns into 0, it doesn't mean every function will have such a point, okay? Not all cubic function will have a stationary point. For example, x cubed plus x, this point just doesn't have the stationary point. So there's no point on this graph the gradient equal to 0. So stationary points of the inflection might not exist for all the functions. So there might be some functions that cannot be turned into inflection form. Y equal to a times x minus b cubed plus c. For example, your y equal to x cubed plus x, you can't turn this function into this form. And there's no point of inflection for this function over here. Alright, I pause it for a little bit so you can take some notes. The next bit is about the sign diagram. This one is basically more about finding out your x-axis intercept, and then finding out whether the y value is positive or negative around this x-axis intercept. Okay, so if the question given you a function in a factorized form already, so you just draw a line, kind of like a line graph over here, and above the line is positive, underneath the line means negative. You find out the x-axis intercept. For here, it would be alpha, beta, and omega, and gamma. So you find out a, beta, and gamma, and then you sub into some values between when x is smaller than a, so when it's this way, when it's between a and b, and when it's between b, beta, and gamma, and when it's larger than gamma. So let's see some examples. The question asking you to draw a sign diagram for x cubed minus 4x squared minus 11x plus 30. If it's given in this form, you need to firstly make it into factorized form. That means you just factorize it first, using what we did in 3D. So using the factor series or using the rational root series, and then you're using the long division. Okay, I don't repeat it over here, but you will get from this one, you will get the px equal to x plus 3, x minus 2 times x minus 5. So now you have your alpha, your 3x intercept, negative 3, 2, and 5. So you draw a line, negative 3, 2, and 5 over here. And now you try to sub into some values. So for x smaller than negative 3, I might try negative 5. Okay, negative 5 cubed minus 4 times negative 5 squared minus 11 times negative 5 plus 30. That would give me a negative number for sure. So I would draw their negative over here because this is positive, this is negative. So smaller than negative 3, they are going to be a negative value. So I just draw a line like this. And then between negative 3 and 2, for x between negative 3 and 2, I might sub inside, for example, 1. Okay, 1 plus 3 times 1 minus 2 times 1 minus 5. That gives me a positive number. Okay, so that means between negative 3 and 2, the y value is going to be positive. So I draw the line above the line, above this number line over here. That means between 3 and 2, my y value is positive. And then we do the same thing. Sorry. And then we do the same thing. For x between 2 and 5, my y, I sub into 3, and my p3 will definitely be negative. So that means between 2 and 5, my value is going to be negative. And lastly, for x larger than 5, I will get probably a sub into 6, and p6 would be larger than 0. So that means from 5 beyond, I would have positive values. So now I have my sign diagram drawn over here. Alright, so that's how we do the sign diagrams. The question will directly ask you to draw it, and once you have it, you just follow the steps. Find the x-axis intercept by the factor series. So you factorize your function into the factorized form first. You identify what are the x-axis intercepts. And then some question might work if you have the y-axis. Okay, this is especially the case for our quartic functions, if you try to draw the graph of it. But for the sign diagram, we just leave it first. You just don't really need to worry about this by far. Okay, and then you prepare the sign diagram. That is something like this. You have your intercepts prepared, and then you sub some values to find the y value between these intervals. So remember, if you have 3 points, there will be 4 intervals for you to draw out. So 1, 2, 3, 4. If you have 3 points, 4 intervals. If you have 4 points, 5 intervals. And then you're just using the plus or minus to determine where are the y values between these intervals. All right, so that's for a cubic sign diagram. And this one is how do we sketch the cubic function. It might require a little bit information that we haven't recovered so far. Okay, so when we try to draw the cubic function, we use the factor series to find our x and y intercept first. Okay, so we're finding out where the graph might touch with our x and y intercept. And then using the CAS calculator or using a calculus method to find out our turning points. Because for turning points, we know the gradient would equal to 0, right? So you have your x, y intercepts ready, gradient equal to 0, so the turning points ready. And then you're using the diagram to see, okay, where are the graph? Basically, are they increasing? Are they negative? Are they positive? Between those x-axis and the turning point? And then you do the graph. Okay, so in this chapter, at least in chapter 4, it won't ask you to draw a graph by hand. Most of the question would ask you to draw the graph using the CAS calculator. But this one is just keep in mind, when we finish the calculus part, we might meet some questions asking you to draw or sketch the cubic function by hand. And that is where you need to use these steps over here. Alright, so that's for our cubic function. We will do some examples in class as well. Some example over here of the sign diagram. And you need to understand how to draw a graph using the CAS. If you find it challenging using the CAS, just email me and I can send you a document about how the CAS is working in general. So there are many different steps, or say like the other things that you can find in that guidebook. Okay, I'll just email you if you find like CAS is really troublesome. And yeah, I already showed the answer for this one. So once you have your fx, or say the cubic function drawn in your CAS diagram, it might ask you to draw something else. For example, here, the fx plus 2 or 4 times fx. And this is where we need to use our chapter 3 information. So you need to remember how do we do the transformation, especially using the function method. So that is method 2, where you just recognize the transformation by looking at what it does with the fx. Okay, so that's for cubic function. I won't mention too much. We will do some examples in class together. And then for f is our quartic function. And it's like to the power of 4 already. Because this function is even, or if you have like x to the power of 6, okay, to x to the power of 8 or x to the power of 10. Because these functions are even, that means in general form, or say in general shape, it will, if it's positive, the graph will always end with a positive gradient. So that means your graph would always be like this. Okay, no matter how many intercepts you have or where is it, you're starting from positive and end with positive. But if your graph is a negative function, then your graph would always be like this or this. So negative to negative. So this is exactly contract with what we have just saw in the cubic function. In the cubic one, we saw the graph would always be like this or this. But for even function, it has always from the same to the same. Okay, positive is positive to positive. Negative is negative to negative. And there are different forms for our quartic function as well. So for quartic function, we still have the turning point form. Now it is not the same as the point of inflection. We have the turning point. So that is when y equal to a times x minus b to the power of 4 plus c. Okay? And we also could have a factorized form where equal to a times x minus b times x minus c times x minus d or x minus e. This is the case where you got different combination. You might have a times x minus b squared, x minus c squared. Or you could have y equal to a times x minus b cubed, x minus c to the power of 1. Okay, different combination here, but they're all factorized already. And the last one is expanded form where you have a times x to the power of 4 plus b x to the power of 3 plus c times x to the power of 2 plus dx plus e. Okay, so these are the 3 forms of the polynomial of the quartic function. And accordingly, by just looking at the factorized form, you will realize there are different points for our x-intercept. So for a quartic function, it is possible that we have no x-axis intercept, because you could have a function like y equal to a times x to the power of 4 plus 3. And this would make your function like this. So your function is always above your y equal to 3 line. Everything will be above of it. Okay, so this is a case where you have 0 intercept. And when it becomes a negative, you could have 0 intercept as well. So your function would be like this. Okay, 0 intercept. And if we write the factorized form as y equal to x minus probably a number to the power of 4, or simply as x to the power of 4, the function would have only one intercept, that is either here or you move this function around, so this a over here. So this is the case where you have only one point of x-axis intercept. This is the same as here. Okay, so this is the 1 point of x-axis intercept. And then we could also have 2 points of x-intercept. That is something like this. It's not really well drawn, but Yeah, you get what I mean by that. Or you could have a different one that might looking like this, something that you should definitely saw before. If it's a negative, you might looking like, oh, it's really bad. Okay, so you have this, and then there's a point of inflection. Oh, or it could be this. What's this? Okay, so for two x-axis intercept, this is where it got a little bit complicated. For this case, okay, you have one point that directly going through, so you have y equal to a times x minus b, and then there's another point that is a point of inflection. So that is x minus c to the power 3. Right? So one point that is just over this, another point that is to the power of 3. That gives you the point of inflection. And for the blue one, this one, like the kind of like two turning points one, this is because remember in cubic function we said when we have repeated factor, you would have this turning shape. We'll say like the graph just touch the x-axis and then moving back directly. So this is where you have y equal to x minus b square times x minus c square. So each of them you have a square. This is your b, this is your c. That touch your x-axis and directly going backward. Okay, and this is same idea for if it's a negative. So that would be y equal to negative ax minus b x minus c cube, or y equal to negative ax minus b square x minus c square. Okay, so this is where you have 2 points of x-intercept. And lastly, when you have 3 points of x-intercept, yes, 3 points of the x-intercept, that is where you have something like this. Draw this one to greatly. So you have something like this. Okay, 1 point going through it, 1 point is a turning point, another point is just going through it. Okay, so now you would have the function would be y equal to x minus b x minus c squared x minus d. So this is the 3 intercept, or say 3 x-axis intercept. Or when you have 4 x-axis intercept, this is when you have something like this. Okay, 1, 2, 3, 4, and they are all just directly going through our x-axis. That is x minus a, x minus b, x minus c, x minus d. They're all to the power of 1. Alright, so these are this picture is not really good looking. I will draw another one after the video and send you through the email as well. So these are the 5 cases for our quartic function with the x-axis intercepting. And just remember, if you have a binomial x minus something to the power 3, that means that point is going to be a point of inflection. If you have x to the power a to the power of q, that is where it's going to be a turning point. And if x to the power of 1, that is just directly going through it. Okay? And if x to the power of something to the power of 4, like this, it's going to be somehow similar to a turning point, but a little bit wider than the turning point 4. Okay? So that's for the quartic intercepting. And for the for the sign diagram, it's the same thing. You draw the line, you find out where are the intercept. For the first one, this is going to be positive 2, this is negative 2, this is positive 3, this is positive 5. So you have negative 2, 2, 3, and 5, and above is positive, underneath is negative, and then you sub some values inside. So you have 4 numbers with 5 intervals, so that means smaller than -2, between -2 and 2, between 2 and 3, and between 3 and 5, and more than 5. Okay, so you just sub into different numbers. For example, I might try -4, that give me, so p -4, that would give me -4, that is a negative number. Okay, so that would be looking like this. And then between 2 and -2, that will give me a positive number. So I would draw here. Between 2 and 3, I might try 2.5. And that would give me a negative number again. And then between 3 and 5, I try 4. That gives me a positive number. And lastly, I have x more than 5. That gives me a negative number. So this is my sign diagram in the end. Okay, and if we're asking you to draw the, let's say the graph of it, to draw the sign diagram of this one, of this function over here, and see it's not a factorized form, right? So we firstly turn into a factorized form using the factor theory. Okay, so you will realize f1 p1 would equal to 0. That means x minus 1 is a factor. And how do I get this one is I try plus or -1 or plus or -2. So I try p1, p -1, p -2, p +2, and I would end up with x minus 1 is a factor. And then I try the long division or using the calculator, and that will give me x cubed plus x squared plus 2x plus 2 times x minus 1 is equal to px. So now I could have px would equal to, I further simplify this one, okay, because this is still a cubic function, so I further simplify this one. I write here x cubed plus x squared plus 2x plus 2. I try to factorize it. If you use the factor theory, you will find p -1, not p again, so probably f. If I say this is fx, f -1 is going to be equal to 0. So I try the factor of this one, -1 again. So you will find x minus 1 is a factor. Or there's another way. Or you can try, for this function, you realize that there are some similar terms between each of them. So x cubed plus x squared. You can have x outside, that gives you x squared plus x. And then plus 2 times of x plus 1. Right? And for this one, you have x times x plus 1, so x squared plus x, and then plus 2 times x plus 1. Now they all have this common number x plus 1, so you put it outside the brackets, x plus 1 times of x squared plus 2. So now you factorize this whole thing into x plus 1, x squared plus 2, x minus 1, and your 3 point is -1 and +1, because this one cannot equal to 0. Therefore, no root for this bracket over here. So you only have 2 x-axis intercepts, and then you try x smaller than -1. That is fx. Px is going to be larger than 0. Between -1 and 1, px is going to be negative then. And lastly, x larger than 1, px positive. Okay, so you have function like this in the end. Okay, so that's it. They won't ask you to draw a quartic function at this chapter by far, but after we do the calculus, they might asking you to draw it by hand. So that means in exam 1 where you don't have the CAS calculator. So for a quartic function, or say for any higher number polynomial functions, find out the x and y intercept first. That's definitely the first step. So x, y intercept using the factor theory. Alright, so using the factor theory to find all your x intercepts and x equal to 0 to find your y intercept. And then using the using calculus, the gradient equal to 0 to find out the turning point. And once you find them, you can start prepare the sign diagram and then start to draw. Okay, so don't worry this by far. I just want to give you guys a big picture of what might come through around the polynomial functions once you've done mostly everything. But yes, just keep this in mind. If you are given a polynomial function, try to use the factor theory to find the intercepts first. And then we find the turning point, and lastly, we are able to draw the graph now. Alright, so that's for 4E and 4F. I hope the things are pretty clear by far, especially the graph for the cubic function and quartic function with 1, 2, 3, or 4 x-axis intercept. And yeah, I will send this through the email. Let me know if you can't understand anything or if you found any part that's confusing. Just email me back. And I look forward to see you guys on Tuesday. Yes.